So hello everybody. Today we are going to discuss about statistical learning. So before proceeding with that, let's understand what does it mean by statistical. So statistics is basically the branch of mathematics that deals with collecting, analyzing, interpreting and visualizing the empirical data. So when we talk of the terminology statistical learning, basically this is the ability to extract statistical regularities from the real world around us. We use this ability, which is known as statistical learning. And other important thing to know about the statistical analysis is basically the difference between statistical analysis and machine learning. So when we talk of machine learning, basically machine learning learns from data. It learns from data that doesn't have explicit program. So when we talk of machine learning, we can in simple terminology says this is basically training a model which is not explicitly programmed, instructions are there. And statistical learning on the other hand basically is rule based learning, rule based programming, which is formalized in the way variables relate to one another. Machine learning learn from billions of data. Billion means huge amount of data. When we talk of statistical learning, we have only small chunks of data. The data is smaller but very much significant. And moving forward, machine learning emphasizes on various things like making predictions, clustering, classification, regression analysis, that is making the prediction, supervised, unsupervised and semi-supervised learning. On the other hand, statistical learning is mostly about making certain inferences from the given data. And statistical learning is very much maths intensive. On the other hand, talking of machine learning, it identifies patterns from the dataset through iterations which require a very less human effort. And when we talk of the various uses of statisticus in machine learning, so we say machine learning is basically based on statistical analysis. It is about asking the questions about the data, cleaning and pre-processing the data, selecting the right features, model evaluation, and then model prediction. We also need to know the difference between population and sample. So it is simply huge. The whole data collection of data, huge amount of data is simply a population. Like we say, when we are talking of a university, there are around 60,000 students in the university, and that is just a population for us. And if our main focus is only on the computer science engineering students, then it means we will select only those CSC students, that is a sample in our case. So basically a sample is simply a subset of population. In hypothesis, we will discuss about this in the very next lecture. For today, we are going to discuss basically on statistics. So talking of statistics, which is the science of collecting and organizing and presenting the data, it is further divided into two types: descriptive and inferential statistics, where descriptive is simply describing something that is being analyzed but doesn't allow us to draw any conclusions. And inferential statistics is a set of methods used to draw conclusions or inferences about characteristics of population. Making inferential statistics is as making estimations and hypothesis testing, whereas descriptive is measures of central tendency, measures of dispersion, tables and graphs. And in this lecture we will focus on central tendency measures. So when we talk of central tendency, so we say a measure of central tendency is one of the descriptive statistics that represents the center point of dataset. Basically, that is, it describes the data in a single value while identifying the central position. So the central position may be identified by mean, median and mode. So as we all know, means in simple terminology is taking the average of something. That is, if we are having numbers like we have having number 1, 3, 4, 7 divided by total number of items is equal to the mean of something. This is a simple way that we calculate mean. It's nothing else, nothing more than the average value of the data points. And understanding about the median. So median is simply the center point when the center point, or you can call the middle point, when the data is arranged in the ascending order. Suppose we have data like 1, 3, 7, 10, 15. Then in this case, this is the central element. So this is the median, which is giving the central tendency, that is one single point. And now in this case, when we are having even number of data items, like in this case where we are having data set 1, 3, 4, 7, so we take two values from the middle, that is 3 and 4, and median is 3 plus 4 divided by 2. So this is how we calculate the median in case of when we are having odd numbers or the even ones. Mode is just most common value in the data set, like we are having elements like 2, 10, 5, 1, 2, 6, 30. Then in this case 2 is occurring 2 times, or it may happen it is occurring 3 times or more number of times, means the most frequently occurring item serves as mode in this case. It's if number value occurs more than once, then there is no mode. If two or more values occur as frequently as each other frequently than any other, then there are two or more modes in the case. In that case we will not take any average, we will go with, we may have more than one mode in a particular data set. And now let's understand when to use this and when to not to use this. Fine. So when we talk of mean, which is the most easy and common media to be used, now the question may arise, which is a very important question from interview point of view, from understanding machine point of view. We have to go with one central tendency. In the previous lecture we discussed about coefficient of variance, that is giving the single normalized value. So how that normalized value is calculated, one of them is central tendency. Now when we talk of this in the point of view of mean value, so it is easy to calculate, very easy to calculate the average. Others are also easy, but mean is most frequently used also. Now the question arises, when to use mean and when not to use mean. The simple answer in that case is outliers. Mean is prone to the presence of outliers in our data. If we have more number of outliers, then that is the case when we should not use mean. Now let's understand why we are talking about this thing. Now suppose I am having the value 2 plus 3 plus 5, that is total 3 values. So mean in this case 5 plus 3, 8 plus 2, 10 divided by 3. So it is approximately 3.2 round. Fine. Now let's say we are having one odd value, an outlier also. Now suppose I am continuing with the same value 2 plus 3 plus 5, and one of the value is 100, which is outliers are basically extended values. We will have one more another video on outliers and noise only, that to differentiate between what do you understand by noise and outliers. So in this case outlier is extended value. In this case if we take the mean, so it is around we can say 5 plus 3, 8 plus 2, 10, 110 divided by 4. So when we go with this, 4 2 is the 8, and then 30, 4 7 the 28, 27 point something. Fine. So there is a big difference between 3.2 and 27. So if we are going with outlier data set and we are proceeding with calculation of mean as central tendency, then we may have a big variation, that is known as dispersion also. Fine. So in that case, which will be a problematic, we should not go with that. Now we have an ultimate solution to the outliers, that is the median. Now why the median is the best thing when we have outliers in the